Insolation means incoming solar radiation. Insolation refers to the amount of solar radiation, sunlight, that reaches the Earth's surface. It is a key factor in determining the climate and temperature of a region. Insolation varies based on several factors. Factors affecting incoming solar radiation. Latitude. The angle at which sunlight hits the Earth's surface is determined by the latitude. Areas near to the equator receive more direct sunlight throughout the year, leading to higher insolation, while areas near the poles receive sunlight at a lower angle and over a smaller area, resulting in lower insolation. Altitude. Higher altitudes can experience slightly higher levels of solar radiation since the atmosphere is thinner and there is less scattering and absorption of sunlight. However, this effect is generally small and more noticeable at very high elevations. Time of year. The Earth's tilt causes the angle of sunlight to change with the seasons, which affects how much solar energy a particular area receives. For example, during summer, regions experience more direct sunlight for longer periods, leading to higher insolation compared to winter. Time of day. The amount of solar radiation reaching a specific location on Earth also varies with the time of day. Insolation is greatest when the sun is at its sky, typically around midday. Morning and evening hours receive less direct sunlight due to the angle of the sun's rays, resulting in lower insolation. Weather and atmospheric conditions. The Earth's atmosphere plays a crucial role in filtering and scattering incoming solar radiation. Cloud cover, humidity, and air pollution can block or scatter sunlight, reducing the amount of solar radiation that reaches the surface. Clear skies allow more sunlight to reach the ground, while cloudy days reduce insolation. Surface characteristics. The type of surface, example land, water, snow, forests, also affects how much sunlight is absorbed or reflected. For example, snow and ice reflect a high percentage of solar radiation, reducing insolation, while dark-colored surfaces like oceans or forests absorb more, increasing insolation. Solar constant. The average amount of solar radiation that reaches the outer atmosphere of Earth is approximately 1361 watts per square meter, is equivalent to approximately 1.937 calories per square centimeter per minute, known as the solar constant. As the size of the Earth and its distance from the Sun are both relatively small, it receives significantly less quantity of insolation. Only 0.02% of total solar radiation reach the Earth's surface, which is 2 units of energy out of 100 million units of energy radiated by the Sun. Earth's distance. The Earth's orbit is elliptical, and its distance from the Sun changes throughout the year. However, the difference in distance is not significant enough to drastically affect the incoming solar radiation. The Earth is closest to the Sun around January, perihelion, and farthest away in July, aphelion, but this effect is small in terms of overall solar radiation. Seasonal variations. Due to the tilt of the Earth's axis, about 23.5 degrees, different regions receive varying amounts of solar radiation during different times of the year. For example, during the summer solstice, the northern hemisphere is tilted toward the Sun, receiving more direct radiation, whereas the southern hemisphere is tilted away from the Sun and receives less solar radiation. Measurement of incoming solar radiation. Insolation is typically measured in watts per square meter using instruments like pyranometers and solar radiometers. These devices capture and quantify the amount of solar energy received over a specific area and is an important parameter in studies of climate, energy production, solar power, and environmental science. Importance of incoming solar radiation. Climate and weather. Incoming solar radiation is the primary driver of the Earth's climate and weather systems. It influences temperature, atmospheric circulation patterns, and the hydrological cycle. Solar power. Solar energy is harnessed through solar panels or other technologies that convert incoming solar radiation into electricity or heat. The amount of incoming solar radiation at a specific location directly impacts the effectiveness of solar power generation. Agriculture and ecosystems. Plants rely on solar radiation for photosynthesis, and the amount of sunlight in an area affects vegetation growth and agricultural productivity. Solar radiation also influences animal behavior and ecosystems. In summary, Incoming solar radiation is a vital concept that influences weather, climate, ecosystems, and energy systems, and is affected by multiple factors such as the Earth's position relative to the Sun, atmospheric conditions, and surface properties.